In this tutorial, I'll use Azure Monitor for containers to show you how you can monitor and troubleshoot the performance and availability of your container workloads deployed to a managed Kubernetes cluster hosted on Azure Kubernetes Service. Azure Monitor for containers is designed to monitor clusters hosted both on Azure and on premises. Due to the distributed nature of microservices and hybrid deployments used in modern apps, some of these clusters may be cloud-hosted and fully managed, while some may be self-managed, and others still may be running on premises. Azure Monitor for containers is also known as Container Insights, and it supports AKS, Azure Container Instances, Red Hat OpenShift on Azure, and self-managed clusters hosted on Azure using AKS Engine, Azure Stack, or on-premises. This is Azure's native monitoring solution, so you can access it directly from the AKS cluster blade by clicking on Insights in the Monitoring section. Container Insights is a component of the broader Azure Monitor service, which also includes several other out-of-the-box insights. These are predefined and curated monitoring experiences for other resources such as VMs, applications, storage accounts, and so on. One of the key benefits here is that it doesn't need the same level of maintenance and overhead in terms of additional infrastructure, complex integrations, or expertise as a third-party approach to monitoring would require. You can also access Container Insights from the Azure Monitor overview page by clicking on Containers in the Insights section, and this brings me to the Getting Started page. Here, you'll see shortcuts to view the state of monitored clusters, to onboard clusters not yet being monitored, and to create alerts. I'll get started with monitored clusters. There are many challenges when monitoring clusters of containers running multiple applications in production-grade environments. The first of which is scale. For the individuals responsible for the administration of these large environments, there may be dozens or hundreds of clusters and thousands of namespaces and containers that need to be monitored. And if an issue arises, they need to be able to drill down to just one node, one pod, or one container to investigate and troubleshoot performance by looking at utilization metrics or analyzing logs. This is a high-level, at-scale view of the status of my clusters in a centralized location contained within a single page. The clusters listed here are based on the subscription selected in Portal's global subscription filter, so I can add or remove subscriptions and the view updates with my new clusters and types. In this case, I have ARO, Red Hat OpenShift on Azure, AKS, AKS Engine, and I also have the ability to filter further by environment, Azure, Azure Stack, or non-Azure clusters. Notice first that there's now a count of monitored versus non-monitored clusters in the tabs, giving me information on where I do and don't already have visibility using Container Insights. The top of the table starts with the cluster status summary. This is simply a total count of the clusters and their current state. This can be critical, warning, unknown, or healthy. I'm also presented with a list of the clusters and their type. Next up, we have the Kubernetes version. And as I continue moving to the right, you can see the cluster status from 4 different perspectives. The status column is an overall worst-case aggregation of the condition of the other 3 columns to the right. The nodes column gives an indication of the state of the underlying infrastructure on a per-node basis. System pods describe the state of the Kubernetes components, i.e. the kube system pods. And lastly, user pods refer to pods which I've deployed. These are related to my own applications. So how can we continue the investigation into what's going on with those clusters that aren't in a healthy state? There are a couple of options here. I can click on the critical status icon in the user pods column, which takes me to the controllers, where I can see the problematic pods and containers. And think of this as guided troubleshooting for the developer who may not be completely familiar with the environment in order to point them into the hotspots or bottlenecks that may be affecting their app. Alternatively, I can click on the cluster name, and this takes me to the cluster view. Now let's move on to unmonitored clusters. These are the clusters that haven't yet been onboarded. It's a straightforward process to turn on monitoring via a couple clicks in the portal. First, I'll click on Enable, and this opens a card where I can choose the Log Analytics workspace where the monitoring data will be sent. Or I can leave the default option, which creates a new workspace just for this cluster. Log Analytics workspaces are a core component of Azure Monitor, and they can store logs from multiple sources in a central location, allowing you to query and analyze logs using a powerful query language. As an example use case, you can choose to send your application logs and performance records to the same workspace where your container logs are being sent for combined app and infra analysis and correlation. We'll revisit this concept a bit later in the presentation when we delve deeper into logs. It's also worth mentioning that the onboarding process can be completely automated using ARM templates, Terraform, or the Azure CLI. So you can add it to your automated deployment and CI/CD pipelines. Back to troubleshooting our problem. I'll start my investigation by drilling into one of the clusters in a critical state. This cluster tab is only one of 5 tabs available on this page. Here I can choose to start my investigation at the different levels in my cluster hierarchy: cluster, node, controller, containers, or deployments. But before we get into the contents of these tabs, let's talk about some of the global filters available up top. You can filter by a time range to focus on a recent time period. You can choose a past time range for more retrospective analysis. Next, you can filter down to a specific service, node, node pool, or namespace. The namespace option is particularly interesting because this accommodates the approach many of our enterprise customers use to deploy and manage access to their cluster resources. And there's also an option to look at live data when you're monitoring an ongoing issue. Let's jump into the cluster view. This lets me know the basic performance of my cluster by displaying the node CPU and memory utilization metrics using average, max, median, 90th or 95th percentiles across the entire cluster. This view also provides a count of the nodes and pods so I can track increases or decreases in the number of pods and nodes resulting from autoscaling due to the changes in load or deployments being performed. For example, if you see a high number of pods in the pending state for an unexpected period of time, you know that you're having difficulty scaling up your nodes quick enough to keep up with your deployments. In general, this view answers questions related to poor application performance because of infrastructure limitations such as CPU and memory usage, and shows them in relation to scaling operations that are being performed. The metrics available on the tab being described here are pretty narrowly focused on CPU and memory. But depending on the constraints in your specific environment, you may want to expand the range of performance data sources to include disk usage and capacity or GPU usage. And in these cases, there are dedicated workbooks to meet this requirement. These workbooks are predefined and interactive reports that highlight the consumption of specific resources. There's also a workbook that shows the billing information with the sources of data collected by Container Insights. Just as a side note, while I'm in this workbook, I'll point out that the Container Insights billing is primarily based on ingestion. That's why it's important to track the sources of data to understand which namespaces are the largest contributors to the data being received. Next, I'll look at kubelet operations, where I can see the type, number, successes, and failures of the operations. I also want to point out here that these workbooks can be used as a starting point for your own customized versions. They can be edited and saved to include content often used by your team. The upside here is that you can use the out-of-the-box workbook queries to jump to log analytics and edit these queries to answer more detailed or specific questions in your organization. Now I'll move on to the Nodes tab. As its name implies, this view presents per node performance information, starting with a list of nodes that you can sort by changing the metric of interest: CPU, memory working set, or memory resident set, and the type of statistical aggregation to be used for the sorting, where you can choose average or any one of several percentile options. For a selected node, you can view additional details and its associated metadata. Here we have the kube version, operating system, and labels including the SKU and the storage types. Now returning to the table, each node is the root of a tree that, when expanded, shows the pods and containers scheduled to run on the node. This gives you the flexibility to compare metrics at the node level to what's actually running on it. Just hover over the trend chart to get a tooltip that shows consumption. Now I'll switch to the memory working set metric. And we can see that for the Minecraft containers on this node, my memory usage seems to be running hot intermittently. This is the actual usage versus the allocated limit. More specifically, this is observed behavior versus allocated specification. This may lead to some follow-on performance problems, which will require further investigation. Before we drill into that Minecraft memory issue, let's look at the problem from a slightly different point of view to see if it's more widespread than just a single node. I'll move over to controllers. This view offers a different perspective than that of nodes. It's all about controllers here, and at the top it starts by showing the type of controller. For example, the first entry here is a replica set. I can expand the controller to show the pods and containers and any related performance metrics and trend charts. Again, I can highlight the controller, the pod, or the container to view its metadata on the right. This is also an opportunity to discuss the scalability of this view. Because I don't have any filters in place, there can be a long list of entries in the table, and it's impractical to scroll through a list with hundreds or thousands of controllers. Instead, I can easily jump to the namespace filter above to restrict the view to the Minecraft namespace, which will make the list below more manageable, or I can also search through this list for my controller by name. Now we can see for all the Minecraft controllers in the replica set, we have the same intermittent high memory usage. In contrast to this problem being limited to what we saw on a single node before, we see that this problem is widespread and affecting all of the containers. The last table explores containers. There's no tree view here. This table just lists each container on a separate row with its current state and performance metrics. As expected, once I select a container, I get access to its details in the right pane, including info such as image name, status, uptime, and CPU and memory requested versus limits. If I keep scrolling down, I can even get into the environment variables for this container. For the top entry in the table, it has a status of terminated, with the reason being an out-of-memory termination, or killed for short. This is an example of Azure Monitor for containers providing guided troubleshooting by showing changes in state and other anomalies in CPU and memory metrics. This kill status is being reported here before the container has been restarted. But how would I see if this happened if I weren't looking at this view just at the right time? One option is to use the links provided here to jump back to the pod or the node view. Additionally, I could also look at the behavior of these metrics in a broader context in more detail and over a longer time period. That makes for a good segue to Metrics Explorer. My scope is already set to the cluster I'm monitoring because I'm only pivoting within Container Insights. And by onboarding to Container Insights, there's now an extended range of metrics that are available from the AKS cluster that can be viewed and analyzed. Looking at the metric namespaces that I can select from, there are now custom metrics from Insights available per node, per pod, and per container. I'll use the Insight/pod namespace to look at my killed container metric, and I'll compare this to the number of container restarts. And this is just the beginning. You can plot these container-specific metrics alongside any other metric to do visual correlation and comparison. In this example, maybe I'd like to look at if my killed containers and restarts are at all related with a reduction in application layer availability or performance, bringing together metrics from other layers in the stack, all collected by Azure Monitor. These charts can also be pinned to dashboards, and these dashboards are real-time views that allow you to monitor resources, and they can be customized to meet the needs of various user roles and shared across teams in your organization using standard Azure RBAC. You can create your own new dashboards for container monitoring or add them to previously created dashboards. In this example, you'll see a range of dashboard tiles related to app and infrastructure, and container metrics are simply one tile within the broader end-to-end view. Even with everything that we've seen so far, it's not always practical to rely on an operator to continuously view a dashboard or to navigate the UI to perform an investigation. Proactive alerting can be used to send notifications or take actions based on some alert condition evaluating to true without any user intervention. To make things even easier for operators, Container Insights has the concept of recommended alerts. These are built-in alerts based on frequently used monitoring criteria. They can be enabled or disabled on the fly, and they can also be modified in the standard Azure Monitor alert creation experience. This means you can drill in and customize the threshold, you can use dimensions to filter, and you can even add the relevant action group for your use case. These recommended alerts are based on metrics collected by the Azure Monitor for Containers agent that's deployed when we discussed onboarding earlier. For this part of the demo, I'll navigate over to the alert creation experience to show the options available for customization. The scope and conditions are automatically set, but I can update the alert to look at only specific dimensions. For example, controllers or namespaces of my choosing. I can also change the threshold or aggregation and evaluation periods. I can also set the action group to send notifications via email and SMS, or to take some actions using functions, logic apps, webhook, or I can even integrate with ITSM systems. Lastly, a couple interesting alert definitions that I'd like to point out are the killed containers alert and the restart count alert. These were the metrics that we looked at in detail before, and these alerts would automatically track and fire on these metrics. With a couple of toggles, the relevant alerts can easily be enabled from this view. Now I'd like to pivot to logs. Not all the monitoring and troubleshooting data that you need will always be available via metrics. In some cases, the root cause of an intermittent performance problem can only be identified by scrubbing through lots of log files to find a particular string or value. However, access to log files in containerized environments may typically be difficult because of some technical limitations and some other practical management problems. On the management side, for large production environments, the correct RBAC for logging needs to be set up in advance for the admins and devs that will be doing the troubleshooting and forensic analysis. And this isn't always easy to know or configure in advance for the right user. In the case of Azure Monitor for containers, I can click to jump into the live data view to see the logs and events for this container right at the time when they're generated. This allows me to answer questions around application performance using Kubernetes standard out and standard error logs. Notice there's a log describing the container being killed and started again, which is another indicator of the same problematic behavior we saw earlier using metrics. But consider, if this log record was a more esoteric one, the same data wasn't available using metrics, how would I approach solving this type of problem? Container environments are very dynamic, so access to live logs is fleeting. You would need to be at the CLI when the problem occurred to view the issue in real time. So to avoid some of these problems, logs are typically exported to an external location for deeper analysis, long-term storage, and archival. In the case of your monitored containers, these logs are sent to the log analytics workspace we described during the onboarding step earlier, and I can get to them directly from this UI. I'll click in View in Analytics and View Container Logs. This takes me to the applicable logs by pre-populating the workspace selection and providing a query that filters to the relevant time range, cluster, and container. So now I have access to all the logs generated by that container, and I can slice and dice them any way I choose. I'd like to analyze how often this container generated the log we saw a minute ago when it was killed. I'll modify the out-of-the-box query to show the log entries that include the string killed, and I'll count how often this happens in 5-minute intervals. And finally, I'll plot this data in a time series chart. The output here is as we expected and lines up well with what we saw earlier in Metric Explorer. Additionally, I can define alert conditions based on these queries as well. If you click on the New Alert button, that takes you to the same alert creation experience that we used earlier, but this time the condition is based on your log query evaluating to true rather than the metric meeting a threshold. Now I was able to modify this out-of-the-box query to plot the chart that I wanted, but what about if you're entirely new to working with logs and you need some help getting started? Azure Monitor Logs includes example queries to help you get started answering common questions. On the left, I'll go to Queries and Group by Solution to see the list of sample queries for container insights. And then I can mouse over the query that I want, where I'm given the option to click Run to execute it or to load it in the editor. I'll check on the number of pods by phase. You can also switch the Group By option to resource type. Then you can expand Kubernetes service to view more sample queries related to your AKS cluster. Let's go ahead and list the Kubernetes events. The takeaway here is that you can use live logs and events for ad hoc troubleshooting, but you can always get access to the historical logs that we've saved for forensic analysis. This enables you to go back in time and investigate issues even though a deployment, pod, or container may no longer exist. And you don't have to be an expert in the query language to start getting value out of this solution. There are a number of example queries available for container insights and AKS. Before we conclude our discussion, I should mention that if you're already familiar with monitoring your environment with open source tools such as Prometheus and Grafana, Azure Monitor for Containers has you covered. There are well-documented integrations for collecting metrics from Prometheus and visualizing data in Grafana. The Azure Monitor agent can scrape Prometheus metrics exposed by your service endpoint, and on the visualization front, Azure Monitor metrics and logs can be displayed in operational dashboards in Grafana. So let's look at the Prometheus metrics scraped by the agent and sent to a log analytics workspace. I'll navigate to the workspace, then switch to tables to look for the Insights Metrics table. I'll then use the Preview option to see a sample of the data contained in the table. And there are two columns here that are very interesting to me. First, the namespace column can include Prometheus as one of the values, and secondly, the name column simply shows the metric name. This means I can query this table for only records that match the Prometheus namespace, and then I can count the number of records for each metric name. So the resulting list will be an example of the Prometheus records sent to this Azure Monitor Logs workspace. With this integration, a Prometheus server and data store aren't needed for storing the metrics. They are available here for queries, analysis, and reporting, just as any other log in the Azure Monitor workspace. I'll now move on to showing Azure Monitor for Containers metrics displayed in a Grafana dashboard. This is based on your Grafana instance ingesting data from Azure Monitor logs and then displaying it in a predefined dashboard called Azure Monitor for Containers metrics. So you don't have to build any of these panels yourself. The dashboard has a few different sections where you can do things like keep track of your cluster utilization and then your pod and control accounts before moving on to things like CPU and memory utilization per namespace. Going even further down the list, we also have per node metrics, such as disk and network usage. And finally, at the very bottom, there's kubelet operations. You can now view your Azure Monitor performance data, and specifically in this case, your Azure Monitor for Containers metrics, alongside all of your other operational dashboards in Grafana. That wraps up our overview of Azure Monitor for Containers. Hopefully, you can leverage what you've seen today to take advantage of these capabilities as part of your broader Azure monitoring strategy.